redox titration. You've already done the normal titration, but I think I will do something uh, just to recap what we have done, especially in the mall, for the sake of the new students, because it is very essential that we, all of us understand um, maneno ya mall. Those should always be there. Let me just open. Let me just open. So I don't know if Maura, you tried the question. Somebody I'm looking for, but I don't think she's already in. I think it is Monica. I really wanted her to be in for the sake of that question that I left the other time, because she tried it, but there were some few errors. I think because of the English now, it has to be the English on this question. So it is not really the chemistry, but it is the English of how it was tested, it was used, this kind of question. Uh, I don't know if you try the question. Can we do the question, or we just go to the to the other one, the redox first, and then
We can try the other one, teacher.
this one is exercise 2.2.
Yes.
Yes, yes. So somebody tried. That is why I was saying there's somebody who tried, but I don't know if she's in now. Uh, so if she's not in, as you wish for them. I don't know. The student who was due again has left, and I wanted to discuss something about filling the table. Um, but I don't know. I will do it again. Of course, it will be repeated somewhere. Hapo chini, when you're doing the redox, because I said direct titration, the back which we are dealing with now, and the redox titration, all of them have something in common, and it is the table. So tukijaza table, I hope you will be in so that we can continue. So this is the question now that I left you with. So it's saying 24 centimeters cube. I don't know now. I'm supposed to open the. Let me just open the whiteboard. I have to calculate this one very slowly. Uh, so let me share the whiteboard. The only problem with the whiteboard is I don't have the question. I tried to copy the other time. I didn't think it was possible. So I'll have to confirm from to refer from another. So thank you very much. You're welcome again. I think there is a problem with the network or something. But I want to. There was a question that I left on back titration. I didn't even want to do the question first. I wanted you to learn something, but because no, but it should come again. Something will come again. Hapo mbele. So I want to do that question. I don't know. I'd shared in the group. Let me just share the same question again. Or I don't know, Maura, if you can share, you can be sharing the question again also, so that everybody can have the question. So that when I'll be solving, you can be going through it. So you just have to minimize one of. So I'm trying to use my phone, but if you get it fast, you can share the question. So let me try. Let me try. Let me try. Just a few. Just a few. I'm going to share it to the private candidates group. Uh, Hopefully everyone can. Everybody, I don't know if you can. It is already shared. You can confirm now because I want to use the whiteboard to discuss this question in length. A little bit of yes. Kila mtu ameona hiyo swali sasa. So I wanted to bring it to this side so that it becomes very easy when we solve it. So it is saying 24.8 centimeters cubed. So this question is like a solved one. It has been solved for you. So in that the question that I left with you with is it doesn't have the filling of the table, which I've always been saying that the filling of the table is very important. So again, I'm welcoming you so that we can continue, but I'll help you with. Yeah, thank you very much, Monica, for joining. Because I think you are the one who tried the question. So I really wanted you to be in when I'm solving this question, and I texted you this morning. I don't know if you got the message. Um, so I will solve this question. I'm only talking now. I'm addressing the new students. After this, we are going to do the filling of the table again, once again, somewhere. So there is no problem. You should not be worried about what you are solving. I'm saying this question now. I hope everybody has the question. This question was solved for you. You don't have to fill the table. So we are going only to do exercise 2.21, and I've shared that question. It's saying 24.8 centimeters cubed of a solution containing 9.8 grams per dm cubed, that is per liter, sulfuric acid required 25 centimeters of a solution containing 13.8 grams per dm cubed of a metal carbonate, which have been given the metal carbonate M2CO3, which M now determine the metal. Okay, for complete neutralization, calculate first of all the molarity of the acid. So that is question one, is the molarity of the acid. So I want to solve that one, molarity of acid. Let me just write for you that way. So there is no problem. I'm saying for the new student, there's something that I love to solve, especially when we are filling the table. So in the molarity of the acid, I'm saying I could not copy that question to this side, and I don't have to write everything. So molarity of the acid. So we have been given acid is 24. Is it 24.8? I hope everybody have or has gotten the. I hope kila mtu amepata that question, so that I don't solve something that is a ghost to you. Yeah.
Yeah, tumepata.
Yes. Just follow it from there now. So we have and then that is 24 centimeters of a solute containing 9.8. So this one is, there is something I want to discuss, especially for the person who solve this. 98.5 9.8 grams per dm cubed. Then before I continue, now I've written that way because it could be written another way, but it is still the same thing. So we are saying this one is 24, and it is something that is 9.8 containing, because they have given you H is equal to 1, so I give you H is equal to 1 because it is sulfuric acid. S is equal to 32, and then we have O is equal to 60. Now this question was very simple, and I think Monica aliona ni rahisi akaamua imekuwa rahisi sana, wacha ni complicate kidogo. That is why I'm normally afraid of questions that are easy with students, because they normally tend to want to complicate that question because of the number of marks that maybe you have been given. But it is not supposed to be the case. So we have everything. I think that one is okay. They've given us for the carbon HC is equal to 12. So let me just put everything here. So this one is what you have been given in the bracket. Now, first of all, we should know that the acid is sulfuric. So you should know how to write the formula. Nilisema it is very important for you to know how to write the formula. Writing the formula of the compound, let us say the molecule, the atoms that you have been given. If you do not know how to write that one, it becomes a problem. So the good thing is they have given us, I think they have given us for sulfuric, I don't know, I think they have given us for sulfuric acid. No, they have not. So they are assuming that you know how to write for sulfuric acid, which is now H2SO4. Don't mind this one. This one is not because the way I'm writing it is because I'm using the CASA. So the RFM for this one. So if I wanted, this one now is sulfuric acid. So it is 24.8 centimeters cube of sulfuric acid. And now this one they have dissolved 9.8 grams per dm cube. That is now kitambo, the other day nilisema dm cube, it could be 1 liter. That is dm cubed. That is interconversion of units that are used to measure a volume. So you can interconvert them where we have 1 dm cubed is equal to 1 liter, which is also equal to, the dm cubed now is equal to, let me write it down here, 1,000 centimeters cubed. Yes, that one is very important. Now remember, molarity, because the question is asking calculate the molarity of the acid. Molarity is the number of moles in dm cubed, in 1 dm cubed, in 1 liter, in 1,000 centimeters cubed. That one is the first thing. So we are supposed to do the RFM. Now, I think you can try and do the RFM. Do I have even to do that one? That is the relative formula mass of sulfuric acid of H2 SO4. I don't know. Do I have to do the RFM for this one? I think you can do that. There we go. Because of course I'll do it for the sake. So of maybe the new students only. But now Maura and Monica, I think you can solve that one, and then you give me the value. I don't know. You can try. You can try. You can try. Very simple.
Teacher,
As yes. Yeah.
98
Okay. Also,
out of
90. RFM for sulfuric acid is 98. Yeah. Now, for the
yes.
sake of the new student, I really wish I could know your name. I don't know. You can do it on the chat. I'll just see it. You can write something on the chat, maybe your name, so that I can be mentioning your name instead of, I don't know. I don't like saying the new student or something. Just do it on the chat. So it is 98. So let me just show you maybe how it is done. So the RFM actually is gotten by adding the individual masses. You add the individual masses of each. So for example, individual masses of each of the atoms. We have 2 hydrogen, so it is 1 plus 1 for hydrogen plus, so sulfur, we have been given that it is 32. So, but it is only 1 sulfur, so plus 32 plus the oxygen are 4, and the mass of oxygen, one single atom of oxygen is 16. So that is why we are saying 16. And then let me just do, for the sake of, okay, let me just do the old way. 16 plus 16 plus another 16. So when you add 2 plus 32 plus 32 plus 48, you will get 98. Now, yeah, Mauro, you can mute, please.
Okay.
Yes. Okay, thank you. So, because you already have 98, and we have the mass that has been dissolved, you can get now the number of moles. So we say number of moles. Let me just use n for number of moles is equivalent to the mass over the RFM. Over the RFM. So we have the mass. They have been told that they dissolved this one. Yeah, in that particular. So you now come and you replace. So it is 9.8 over 98. Which now you get, of course, it is 9.8. As I said, 98 over 98, but now the other one is you multiply by 10. Or you divide by 10, yeah, Ju. So you get, this one you just input into the calculator. 0.1 moles. Now, this is where now nako kwa Monica. So actually, Monica, you got this one correctly. Now, but the problem came in, you decided this dm cubed is not making sense. So the molarity of the acid that you're given, actually, you have already gotten the molarity because they're saying we have dissolved 9.8 in 1 liter or in 1,000 centimeters cube. You are not supposed even to be worried about the 24.8. So the molarity of that acid, the molarity of this acid, ndio hii sasa. So it
teacher,
is, yes,
okay, nilikuwa sifai
0.1 m.
kuproceed because
Yes,
kuna hapo
you already
nilipata
gotten the answer. Yes, yeah, that is why I wanted you to be in. Yeah, I wanted you to be in so that you see. Now, the reason why you are not supposed to proceed, let me just give you the reason why. You see, they have dissolved this one in 1 liter. Sindio?
Yeah. Yes.
So, na nilisema when we dissolve a certain mass in a liter, it qualifies as the molarity. Yes? It qualifies as the molarity. Yeah, so we already have the molarity of that one. So iko sawa. Si imekuwa sawa?
Sawa teacher.
Yes. So that one is very welcome very much, Abdi. So I have your name now. Abdi, welcome very much. I don't know if you understand it. Again, you can do it in the chat, either on the wall of the Zoom or the other side. There's no problem. So ukishapata hiyo, the only reason why you have that volume is actually to show the number of moles that react. So you can use that one to get the moles. Now I don't even have to do that one. I don't have to do that one. Now the reason why I don't have to do that one is because the molarity, the volume that was used of the acid and the carbonate is almost the same. If you realize, they're almost the same. So you are getting 24.8 and the other one is also 25. So the difference is 0.2, which in the molarity it could be 0. For this one, it should be 0.099 or 98 or something. So that one, so question number 2 is saying, but now they've given us the mass. They've given us the mass. So it is very important for you to, so the second question is saying, calculate the molarity of the carbon. So can we do the molarity of the carbonate? Still do the same thing. I have zoomed to the maximum. If it is kama unataka kuona yote, I can still zoom out like that. Yeah. So let me just do it that way so that everybody can see. So question number 2 now is the molarity of the carbonate, which is quite easy. So question 2 is the molarity of carbonate of M2. Let me just write M2CO3. Now, so kitu ya kwanza hapa sasa ni watu waandike equation. So the first thing, which I think you did very well, Monica. So the first thing you're supposed to do here is write the equation. After writing the equation, you still get you get everything from the equation. So the equation is H2. So you are writing the equation for, so you did very well here. Yeah. Which nilikuwa nimesema wakikupea I don't know, there's something I'm supposed to touch on again kidogo, which is called the basicity of the acid. If they give you an acid that has a basicity of 2, that means it has 2 hydrogen, and the carbonate belongs to group 2, then you have a better chance. Now, when also they give you with one that has a basicity of 1, and then the carbonate, the metal belongs to group 1, inakuwa rahisi. But when it has a basicity of 2 na metal ni group 1, students kidogo wanakuanga na wanachanganyikiwa. I'll show you in this one. In this example tutaona vizuri. So plus the M2. Of course, you should know the rules of writing the equations. Because I'm using the whiteboard, sometimes I could mess up because it is not a touch screen. I'm using the cursor and the left whatever. So inaleta shida. So and then I put this arrow. It is very important to have that arrow. Now the arrow in chemistry is the equal sign in mathematics. So hiyo haina shida. Now, so then now, of course, you should know what is coming after this one. So we'll have the water that will be formed. Is it the sulfur? So hapa sasa ndo watu people normally get confused kidogo. Is it the carbon dioxide or the sulfur dioxide that is being formed? So we'll have the metal sulfate. So have I written this one correctly? Yeah. Yes, so it should be M2CO3 for the carbonates. Now, the only issue with this one now is knowing. I don't know if that one I've written the correct one. Let me confirm again. Yeah, it is M2CO3. That means the M belongs to group 1. The metal actually belongs to group 1. So that means whatever you get here again will be M2. Yeah, this is where now, Monica, nataka uone. Do you know how this one came to be? I'll explain. Wacha niandike tu kwanza the equation and then we explain. M2 sulfate. Yes. Okay. Plus water. Of course, there is water. There is always water. I'm not going to write today plus CO2. Yes, Monica, now you can unmute and say something before I continue.
Yeah, tu si tumesema inatoka from carbonate. Kana
Yes,
valence of 2.
Yes. Now, I don't know. Have you checked your answer?
My answer.
Yes.
Hapo ratio teacher ilikuwa 1:1.
No, I'm talking of writing the equation. No, writing the equation.
Equation.
Yes.
It's just kama hivyo. It was just the way you've just written.
Can you confirm
And it
again
was
if it was
balanced.
no? Can you check again? Now I'm giving you a minute to check again your error.
Yeah. I can see.
Yes. So those ones are very small errors, but they can cost you. This one is because actually when you talk about radicals, we are talking about radicals with a valency of 2, carbonate, sulfate, sulfides zote ziko pamoja. So hapa ni 2 negative na hii itakuwa 1. That is why we have another 2 here. Now na yako, the only reason you got that answer is because now you assumed actually yako mole ratio iwezi kuwa 1:1. Ukibalance, it might not be 1:1, but it could be 1:1. So you just count M2, M ni mbili huku, hydrogen 2. The sulfates are 7. No, the oxygens are 7. Sulfur is 1:1. Carbonate is 1:1. You can see carbon here. Oxygen is 7. Alafu kikuja huku ni 4, 5, 6, 7. So unaona yangu ni balance. Now I want you to check yours if it is balanced. It won't be balanced. Ukiona vizuri haiwezi balance. Yes, Monica? Will it balance?
Teacher asked me confirm.
Yes. I'll just give you time because we are here for each other now.
Yes, haija balance nimeona.
Yes. Yeah, haiwezi balance. So if the question is kwa the M.
Yes.
Yeah, so if the equation cannot balance, you'll have a problem. That means you will not get the mole ratio. Now, because yetu tumesema ni balance, of course, I have not included so this one is actuous. I have not included these ones. There is no problem, but you must include them when you are writing the equation. It is very important. Actually, especially so that unajua huko mbele unaweza kuuliza to write the ionic equation. I think we'll do an ionic equation for this one. So we have liquid, and then we have gas. No, we'll write an ionic equation. It is not in the equation. It is not in the question, but I think we'll do one. Tutaandika moja. Now, after you're done with that one, you can check now the mole ratio. And the mole ratio, we are talking about the reactants. Easy. Let me just tackle them. So So hizi peke yake ndo tunaongelea. Do not touch the other side of the reactants, especially when they're asking you this kind of question. Hatujafika hiyo place ya kuulizia the other side, so we only touch the reactant side. So tunapata, so the mole ratio of the acid to the carbonate. So let me just write mole ratio. Let me use MR for mole ratio. Mole ratio of acid. So acid is the sulfuric acid, which is the first one, to the carbonate. Carbonate. I'm very sorry for the handwriting. That is not actually my handwriting. I have good handwriting. So mole ratio of the acid. Mole ratio of the acid to the carbonate is 1 to 1 to 1. Yeah. 1 to 1. So it is 1 to 1. So because it is 1 to 1, and you already have the molarity of the acid, which is 0.1. Yeah. So hii pia itakuwa nini? 0.1. Sijui kama mnaelewa what I'm doing. We already calculated the mole. Let me just move it a little bit up. So we have the molarity of the acid, which is here. Sorry?
Yes.
Yes. So na mole ratio ya acid hapa ni 1 mole of the acid is reacting with 1 mole of the carbonate. So if 0.1 mole of the acid in a react, that means it will react with 0.1 mole of the carbonate. So the molarity actually of the acid was easy to identify. So you just had to do the mole ratio, and then you say now the answer to question B is 0.1 capital M. Now we have not even started using the 24 and the 25, by the way. We have not used, but it will be used somewhere. You will see where it will be used, and it is in the third question. So it is used in the third question. Is it the third? Yeah, we have the third and the fourth. So formula mass of the carbonate. So we can use that one now in the formula mass of the carbonate. And then they are saying the relative atomic mass. So in question 3 is answering question 4. So we already have the molarity. We already have the molarity of that one. Mumeelewa venye hii inafanya. This one was easy because you know the reason why it becomes very easy is because they have given us already they've given us the mass that has been dissolved in 1 liter or in 1000 centimeters cube. Sometimes now they will not give you this one. Watakwambia imekuwa dissolved in 100 centimeters cube. So that is now something different. Lakini hii wamekuambia it is dissolved in, we have dissolved it in a liter. That like 9.8 grams per L, per liter, per 100, per 1000 centimeters cube, per dm cubed. That is the relationship. So the number 3 now, let us answer question number 3. We have tumeka sana hii swali, but it is okay. I hope people understand. Yes.
I have a question.
Please. Should I move down?
No, just hapo tu iko sawa.
Okay.
To what extent should you use the volume and 1000? Sababu pia kuna hiyo formula molarity is number of equals to number of moles over volume times 1000. But hii nyingine moles, because kama ingekuwa inauliza tu find the moles of the acid, okay, ingekuwa rahisi because utajua 2 moles is equals to mass over FM. But sasa another formula ya molarity is number of moles over volume times 1000. Sasa ama number of moles over volume per liter, grams per liter. Sasa teacher, wajua sometimes
I
ina
think I think I understand your question.
Yes.
So I understand your question. Now, the reason why 24.8 centimeters was there actually is kuleta hiyo kitu yenye umesema sahi, to bring about confusion. But they are saying So you are supposed to be worried about the grams that has been dissolved in 1 liter. That is actually giving you the molarity. Now, if I wanted the moles that reacted in that equation, now, how we normally make these solutions, let me just make this one clear. How we normally make the solutions is I normally measure the mass, for example, 9.8 grams, and then I dissolve it in 1,000 centimeters cubed. I will not give you the 1,000. I'll not give you the 1 liter ufanyie kwa practical. I'll give you the 24 centimeters or the 30 centimeters to use in the practical. That is why this question is kind of confusing because we don't have the table. You remember I started with that one. It is an easy question because I've given you the answers to the table. Yeah, wamesema table sasa wamekupa 24.8. So you are not supposed to calculate that one. But ukiwa unajitafutia, it is quite fun rather than this one. So yenye wamekuambia ni umetumia 24.8 na mwalimu aliunda hivi. You remember tukifanya the other one pale tulikuwa narudi to question where you are given and then they are saying solution A has 0.1 molar of a particular solid or a particular liquid. Mnakumbuka huko juu. In that question they were giving us a question. Do you remember the question that we did the other time? Well, you have
Yes.
solution A and B. Yes. So hii wametoa hiyo part. They have removed that part. That is why I was saying it is very easy. At the same time, it could be a little bit confusing, but it is very easy question. Iko sawa. So they have only removed some parts, but a question like this, you might not be given actually in the practical, but it can come in the theory part. Because actually the moles can be tested anywhere. But the mole is normally better in paper 3. In paper 3. Yes. Imekuwa sawa.
Oh, teacher.
Yes. So don't be worried about this one. The only thing all of you are correct. So you are correct to ask. In fact, that is a very good question. Juu unashangaa, we have a formula. Lakini formula I apply huku mbona, which is okay. So it doesn't apply because we have removed some of the part of the question. So this one was a direct question. It is not a practical question. Wametoa pahali wakasema tunafanya hapa. Now, question number 3. So there's something I'll deal with in the redox. I'll have to we will end this class a little bit early, maybe 9:20 or something. I have another meeting. Of course, it was starting around 8:40. But I know people are just doing introductions and the rest. So najua nikiingia, I'll just use it. Nitaingia baadaye, maybe 9:20. So we'll end it today a little bit early. We can make it up another time. I hope that one is okay. Now, so question number 3 saying the formula mass of the carbonate. Now, so hapa sasa ndo tunatumia ile kitu. So the carbonate have been given that it is a 25 centimeters cube. So first of all, the carbonate. So let me just write the name of the carbonate, M2CO3. So we have the mass that have been given. So it is 25 centimeters. So they are saying 25 centimeters cube. And this one was supposed to guide you actually, ujue mole ratio huko. Ndo ujue hiyo vitu venye 24 and 25 they are very close, eh? So we have 24 centimeters cube, and then this one is 13. I don't know, they have said 13.8 or 13.6. 13.8 grams. Huh?
Yes.
13.8 grams. And remember, this one also is per dm cube. They have dissolved that one in 1 liter. So there is no problem. You should not even be worried. We can use the same formula. We have the formula, number of moles is equal to mass over RFM. Listen to you. The way we solve the first one. I don't know if you are getting the place I am focusing on, Monica.
Yes, teacher.
Yes, so we use that formula. So we say number of moles is equal to the mass over the RFM. Over the RFM mass. So this one, so we have the number of moles in a liter. So there is no problem. So it acquires faster the number of moles in that 1 liter because they have dissolved. This one is helping us here. Are you seeing there's a place they're saying it may dissolve in 1 liter? So we have 0.1 moles is equal to the mass, which is 13.8 over RFM. So you can solve this one. So you can cross multiply. So this one actually we normally say any number that does not have anything is over 1. So then you cross multiply. So this one is the RFM now. So this one you can use a calculator. RFM is equal to, I think it is 13.8 over 0.1 over 0.1. I think it should be 138. Yeah, is it 138?
Yes, it is 138.
So tuko na RFM iko sawa. So tumepata RFM 138 because of the mole ratio. Now we are using the mole ratio. But if I wanted the mass in 25 centimeters cube, ningesema 13.8 is in 1000. What about 25? Tuko sawa. The same with ile ya kwanza. If I wanted the mass in 24.8 centimeters cube, nasema 9.8 iko in 1000. What about 24.8? But that one is not the question that was asked today. But sometimes they ask that question. So we have answered question number 3. Have we answered question number 3? Formula mass of the carbonate. Yeah, we have gotten the formula mass of the carbonate. And then, of course, the last question is the relate. Of course, wakiulizanga RFM, where the next question is RAM. Yeah. So so I continue. So I want to use the same place. I want to use the same side. So I do that line so that I use that same side. So question number 4 is RAM. RAM. So RFM. So how we solve this one is RFM. RFM is equivalent to RAMs. RAMs. Let me just do RAMs. I hope you can remember these ones. RAMs of M2CO3 individual each. This one I don't know. Let me move it aside. This way. Yeah. The good thing about the whiteboard is you can move it. RMs of each one, carbon, which is M2, Bil, carbonate, and oxygen. Yeah. So RFM is equal to individual. So we have 138 is equivalent to RM ya M ni 2M we do not know. M Bili plus carbon, we have carbon which was 12, tulipewa hiyo, plus 16 mara tatu, plus 16 plus 16 hizi zote. So I don't know, is it 48, 50, 60? No, 60. So you can check. So this one, no, you add this one first. 12, this one is 28 plus 32. I think it is around 60, yeah? So 138 is equal to 2m plus 60. Sindio?
Yes.
Yes. So in hesabu, sasa we go back to hesabu. Hesabu inatuambia kama you have something that is positive here, when you bring it to the other side hivi inakuwa minus, sindio? So inakuwa 138 minus 60 is equal to 2m.
78.
78. So 78 is equal to 2m. Because you divide by 2 over 2 over 2. So m now is equal to
39.
39. Which metal? They normally ask, sometimes they'll ask you, which metal could this be? I don't know. I don't even know. So it is a carbonate. That is. Now you can suggest even the. In fact, unaweza jua by the way kama ni. So we know that is, first of all, it is in group 1. So in group 1, 39, sodium is 23. So yenye imebaki kwa group 1 yenye tuna study ni potassium. Hey, potassium. So this one is potassium actually. They normally ask you, can you suggest? Imekuwa hili sasa hiyo swali. So we have already done that question. Done with that question. But that one is not a problem kumaliza swali. Shida ni watu wameelewa swali yenyewe. Yeah. Now, especially that part where you are choosing, you are given the volume with the mass that has been dissolved in a liter. Now, that one, I think, I don't blame you, it is confusing, especially when they give you a volume, alafu anakwambia hii mass imedissolviwa in a certain volume, which is, now, if it was saying, if the question had stated this way, let me just rephrase the question for understanding. If the question had stated, let me read that question. We read together. So if the question had stated 24.8 centiliters of a solution containing 9.8 grams in 100, it would have been a different story. It would have been different. It would have been a very long one. But because now they're saying it is in per liter, that means when you dissolve something in a liter, I want you to remember when you are preparing solutions, preparing of solutions, ukiwa kwa that place, you will realize that we are preparing, when you prepare, you dissolve to make, when you dissolve to 1,000, it is making the molarity, which is the capital M, rather than the small m, the number of moles. So sijui kama tumeelewa before we move to something else. Of course, we can try another question. For the people who are looking for that made familiar, my made familiar, the one that I got, actually the one that I was given is 2016, which is very old. 2016 is like 9 years late. So that is why I don't want to give out that one. It is very confusing. Mtu atasema na sasa ya 2017, 18, 19 to 2024. So I wanted the new edition, which I don't know. I don't think it has been uploaded, but I found out it is around how much? Around 750 or something, or 735. So if you need to buy it, you can order it online. It can be ordered. It will be delivered. But there's no problem. We'll continue doing. So if you have understood that question, there is another question that was left. The question number 2. You can try question number 2 of that in that exercise, which is saying 25 milliliters of a solution of an acid HYX containing 0.1 moles in 1 dm. Mnaona sasa hiyo wameleta molarity pia. That is the molarity. 0.1 moles in 1,000 centimeters. That means it is 0.1 m, capital M. Reacts with 75 of 0.1 mole. What is the value of Y? So I think you can try that one. It is the same thing. So you can try that one. So that we move on to. Now I might not really do, but I will do for the sake of Abdi. We'll do filling of that table again in full, because it is better even for us to get the 5 marks, full 5 marks. So we'll do that example again. But before we go there, let me stop sharing and then we go to something else. So we are out of the whiteboard. We are going to something else now. So let me check very quickly. So I hope you have understood that one, Monica, especially because imekuwa sawa sasa.
But pia nitafanya ingine then
Yes.
nitatumia.
Yes, that is what I was saying. The way we can understand these things is if we do more practice. More practice, you become better. Now, there's something I want to mention. We didn't mention it in the other book, so I'm going to look for that one. Let us check. No, let me wait for that one to share. And okay, I hope everybody can see now the screen. I don't know if it was the basicity of the acid now. Yeah. So maneno ya, I wanted to discuss something before we go to now filling the table again. Now. Yeah. The number of hydrogen ions which can be produced by a molecule of an acid on ionizing is refers to basicity. So I normally tell people actually basicity is the number of, that is why I said basicity is the number of hydrogen ions that are contained by, is the number of hydrogen ions, which is normally acid ions. I don't know if you remember that when we are writing acids in an equation, an acid, now let me just write for you, an acid is normally written this way. Acid is normally represented as hydrogen ions. That is how we denote an acid. Now, the number of hydrogen ions in an acid is what we call basicity. If we have 2, we say it is dibasic because there are 2. If we have 1, we say it is monobasic because it's only replacing 1 hydrogen ion. Now, it goes to the same way. I want to say this so that people cannot be confused now. A base is normally denoted as OH negative. OH negative is not basicity. Watch and say it. OH is not the basicity. When you talk about basicity of an acid, we are talking about the number of hydrogens that can be replaced. Now, for example, and this one, I'm saying this because now when you're solving the equation, when you're solving those calculations, and you have the equation, sometimes maneno ya basicity na inakuaffect, especially you don't know whether this one is a monobasic or a dibasic or a tribasic acid, na hiyo inaleta shida. So when you're writing the equation, it could bring about problems. So it is very important for you to know the basicity, and I'm also telling you that it is very important for you to know Maura mute. Yeah, so it is very important for you to know the basicity of the acid. Na nimesema sometimes they will ask you the question itself. They will ask you what is the basicity? What is basicity? So nimesema it is the number of hydrogen ions in an acid. Now, for example, now we have examples. So we have examples. HCl, which is hydrochloric acid, basicity, it is monobasic. Nitric acid, monobasic. Sulfuric acid, you saw it as H2SO4. Dibasic, we have we call it alkanoic acids. Most of the alkanoic acids are normally dibasic. I don't want to talk about that one at the moment. Reason being, it is inorganic chem, so we are not even touching that one. Phosphoric acid is normally the special one, which is normally tribasic. That means it has 3 hydrogens. So when it ionizes in water, it will produce the hydrogen. So you will be seeing H ni moja. When it has two, for example, sulfuric ion is, yes. But now in the other ones, in ethanoic acid, alkanoic acids, we only have one because the other one is normally OH. It normally takes part in O and H. So it only has one. But we don't have to talk about that one. We have a reaction between ethanoic and ethanoic acid. Normally leads to what we call an ester. So we don't have to touch on that one today. So I just wanted you to know the meaning of basicity of an acid. So basicity is the number of hydrogens. It is the number of hydrogens, replaceable hydrogens in an acid when it ionizes. And when it ionizes means when we are adding water, because most of the acids that we use are diluted. And to dilute an acid means you have added what? You have added water. I hope that one is okay. Now, for the last thing that we are going to do, let me just, for the sake of Abdi, I want us to fill a table, and then we can do, because we are supposed to do redox. I'll introduce the redox a little bit. I don't even use the KLB because it is a little bit wide, but I'll explain using the long one. And then we can pick it from there. Yeah, so that is okay. So that I have a chance also to share to nagawa knowledge this side and the other side. So okay. Let me check if it is or not. So I want to share something else. I have changed the book that we are using. So this one is the question that you're solving. I hope everybody has gotten an idea. Now, and I'm still repeating this. The moles, the way they normally tell you in a sub, more practice, more understanding. The same, it applies to moles. Ukifanya, the more you do it, the more you will unaelewa. So ukiendelea kufanya, the more unaelewa. Now, and I don't know if I think I'll get another question. I don't know. I think I'll get another question. I had a lot of questions, but I shared it to the group. If you want to get the questions, the other questions, a lot of questions. There is this form 3. No, I think it is a topical questions. I shared the topical questions. I think I'll share it for the sake of Abdi also. I think I'll share the same. I'll share the same. So I'll still share that maybe later on. Now, redox titration. Now, of course, redox from the word redox. I hope everybody can see the screen. Redox means it is a titration where oxidation and reduction takes place. When you have reduction and oxidation, it takes us back to oxidizing agents. Oxidizing agents, manganate 7, dichromate, those ones. So this one is a titration where oxidation and reduction takes place at the same time. Now, that means it involves two processes. So because it involves two processes, I want to just mention something today that we are going to use it in form. I think it is normally in electrochemistry form 4. So the reason I normally like this book is because it brings us back in a letter to kumbuke na vitu tutatumia. So loss of electrons is normally from a reducing is normally called oxidation. That is loss of electrons. I'll give you a formula now before we end this topic. Before we end this lesson, there is a formula I normally use. So this means what has happened here, where we have let me just explain. So where we have so where we have this one, let me just show you what oxidation means. Unaona hii ilikuwa positive 2, alafu after the reaction it becomes positive 3. What has happened to this one is oxidation. The same with this one. This one is 0, alafu ikakuwa plus. That is oxidation. If it changes, if the number was smaller na ikuwe kubwa, that one is oxidation. And now oxidation involves loss of what? Electrons. The thing that undergoes oxidation is a reducing. See, I don't know chemistry. I don't know how it came to be, but I will explain better. So, I'll give you the formula. So I'm rubbing that on fast, so that will bring confusion. Now, nasema that thing that undergoes, or that substance, let me say that substance. I think thing doesn't make sense. That substance that undergoes oxidation is a reducing agent. That substance that undergo, for example, in this case, I think we'll be talking about that one. The reason I'm very particular about this one is because tutatumia pahali. It will help us somewhere. Now, when something gains electrons, it is called reduction. It has undergone reduction when you gain an electron. Now, for example, let me just show you. This one is 0. So this one is 0. Okay. Hapa ni 0 na imekuwa -1. So which one is bigger between 0 and -1? Because 0 is better than -1. So because it is, yes, because it is coming down. Yes. So because it is coming down now, it is undergoing what? Reduction. And that thing that undergoes the reduction by gaining electrons is called an oxidizing agent. Now, let me give you my formula. In summary, if you don't want to forget reduction and oxidation process or reaction, which normally comes, it cuts across from form 2. I think it starts, reduction and oxidation starts in form, even form 1. I think it started in form 1. Pale walikuwa wanasema oxidation na reduction. In form 1 tunasema oxidation is addition of oxygen. I was saying reduction is removal of oxygen. Now, when you are in form 3, 4, form 2 to form 4, we'll be telling you actually reduction is gaining of electrons, oxidation, loss of electrons. And I normally use this formula everywhere. Let me just write. Oil rig. Oil rig. Oil rig. I don't know if you have you ever heard of this formula before? Have you ever used this one? Oil rig.
No.
Just write it. So let me just give you so that it can help you. No, I want to write it the correct way so that it becomes easy.
Okay.
Yes, if this has. Don't explain. If that is better, so that it becomes easy. So anytime this formula will apply in the mole, it will apply also in electrochemistry. That is in form 4. It also apply in what do you call this thing? Is it electrochemistry? Electrolysis. In apply pia kwa electrolysis. So sometimes they ask you which compound has undergone reduction, but which one has been reduced. Yeah, so it applies in the ones I've mentioned. Upper electrochemistry, it is very important actually in electrochemistry. It is I normally use it in electrochemistry a lot. It also apply in electrolysis. That is in form 2. See, in form 2, electrolysis. So oil rig, we normally say oxidation. So I'll write in full. Let me just do it in full. You can write it also somewhere. If you are taking notes, it will help you. Oxidation is losing electrons. I know is losing. How do you write losing? Is it this one? Yeah, it is the single S, the single O, sorry. Losing electrons. Alafu reduction. Alafu sasa you can know it is the agent that undergoes that is the opposite. Because reduction is gaining electrons. Gaining electrons. So mutumie hii, ukienda kufanya electrolysis, wewe ona tu yenye imegain electrons has undergone reduction. yenye lose undergo what we call oxidation process. Now, problem comes in now to the student side. So pali inakuanga shida, ndio wamekuuliza which one is the oxidizing agent and which one is the reducing agent. So yenye ina undergo oxidation, hii yenye ina undergo oxidation is what we call the reducing. This one actually tumeintroduce there is a topic in Form 4 tumeintroduce by the way, na karibu tumalize. It was reducing agent. Don't forget that one. Kabisa. And it is reducing agent because now it has taken what? It has been oxidized. So inachukulia ule, in short, we are saying when it undergo oxidation, anachukulia kitu ule mwingine. Alafu mwenye ana undergo reduction, anapea ule mwingine kitu. Exactly, that is in summary, in Kiswahili. I don't know, this one is the oxidizing. Mushike hizo tu. For today, I want you to mushike oil rig. Oxidation is losing of electrons. Reduction is gaining of electrons. The one that undergo oxidation is the reducing agent because it has taken something from the other one. It is taking something from the other one, so it is a reducing agent because it takes something from you. Now, the ones that undergo reduction has given out something that is burst, it has been reduced, or it has undergoes reduction because imepeana kitu, so it is an oxidizing agent. Can I rub it? Iko sawa? Is it better that way, Monica, now than writing it in? Ukiandika, so that is how you are supposed to identify the reducing agent, the oxidizing agent, and it cuts across from Form 2 where you are given electrolysis, where you are told, especially lead iodide or lead bromide, so you can identify which one has undergone oxidation. And of course, if you can identify which one has undergone oxidation, you can identify which one is a reducing agent, which one is an oxidizing agent. So I can rub it now, so that I go to redox. I can explain something in redox, and then we fill one table. Yes. So I don't like opening the whiteboard unless we are solving a a question that I don't want to solve it here. So that is why I normally go to the other side and come back. Now, so in redox, now unlike the back and the direct titration, where we were using, most of the time we were using, anytime you see you have been given the indicator, when you're given the indicator, most probably that one will be back or the direct titration. Now in redox, sometimes they could not give you that one because you are using oxidizing agents. Now, and in oxidizing agents, ukiona time ingine wamekupea potassium dichromate, potassium manganate 7, which they have given you inclusive of the names and the formulas, by the way. So, and if you mess up the formula, you normally get it wrong. So in oxidizing agents that we normally use are these ones, mainly these ones are the ones that we use in the lab because they're very cheap. Actually, these ones are very cheap. So, and they're normally acidified, and how we acidify them is by adding a small amount of an acid, mostly sulfuric acid, because it is very concentrated. So we normally use sulfuric acid. So we do not normally use HCl because it will be oxidized to chlorine. Now, chlorine is not really good gas when taken in large quantities or when inhaled in large quantities. So that is why we use sulfuric acid, which is not normally oxidized. Now, so you have been told why. So I think this one, nobody ever tells you why HCl is not used, by the way. And they normally say it is only acidified manganese 7 or dichromate. Of course, I've left out the name potassium because the most important side that is being affected is MnO4, Cr2O7, where it will be changed to manganese, and the other is chromium ions, and there is color change. Now, so the reason why you are not giving, you are not normally given maybe the indicator. Remember, huko juu tulikuwa tumesema indicator shows the endpoint. So this one would not actually need the endpoint because there will be color change when this one is oxidized or when it is, or most of these ones are normally oxidized. When this one they are normally undergo oxidation. Yeah, when that one happens, mara mingi there is be color change. Let me just show you that one before we go. So in this situation, an indicator is not necessary. That is what I told you. The oxidizing agents are used as self indicators because there is color change. Yes, there is color change. So sorry, I don't know. Have okay, I think I've skipped something. I didn't want to skip that one. Yeah, it has skipped to the next page. Yeah, we are here. Yeah. So we potassium manganate 7 normally the oxidizing agents. Remember tukiwa ile ingine direct and the back tulikuwa tunasema tunaongeza phenolphthalein na ina change from. I think this one would have been better if you were doing it practical. But I heard that there is still preparation for the practical. You'll do it, by the way. It will be done this month. So, madam, even we spoke with madam yesterday about it. So it is still being planned. It will be done. I don't know. They said it will be done in. I think it is Nairobi, which I think it is okay. The only problem is now people who come from far away like me. I don't know. I think we'll try. If I can get time, I'll still come so that tunasaidiana wote. So so potassium manganate. So we have the color changes now. So nilikuwa naambia, so it is normally purple, it will change to colorless. So inakuwa indicator peke yake. So I don't have to add phenolphthalein or methyl orange. So it becomes that one. I'm not going to touch on these ones today. So I'm skipping that one intentionally. Yeah? Oh, they have left out something. So I wanted to talk about potassium manganate 7 is changing from purple to colorless. The dichromate now. The dichromate, you will see. It normally changes from the word orange. It normally changes from orange E. Let me just write for you because I was looking for that. I thought all of them were here. So this one is tumesema hii ni purple. Now if you remember maneno ya Kanyari, ile maneno ya Kanyari alikuwa anatoa vitu kwa miguu za watu long time ago. I don't know, it has been long. Yeah, he used to use now potassium manganate 7, alafu anasema ni damu inatoka. I don't know how people believe that. I still don't understand. So, but I don't normally judge people based on their faith. So I know people normally are convinced differently. So purple, this one changes to colorless. Now, potassium dichromate is normally orange. And this one, nasema wakikupea hii, this one is better. Actually, I will say this one is better than using methyl orange. Because methyl orange normally changes from orange to yellow. I don't know which is, yellow to orange, which is not making sense. But this one changes from orange to green. Now, if something is purple to colorless, hiyo unaona, hiyo inaonekana very clear. It was purple alafu ikakuwa color, ikakuwa kama maji. That one is very clean. When it is orange to green, easy. It was orange, it is no longer orange, it is green. So that one is easy to use. So these ones are the main ones that we use. Now, I am hoping that we're going to do an experiment that involves adding or using the normal indicators, kina phenolphthalein, kina methyl orange, and also using any of these oxidizing agents, which normally is decolorized or it changes color. Let me just say decolorized because orange and green still maintains as a color. Iko sawa. I hope everybody is there. So redox, mara mingi, we might not really, you will know. Actually, you will know. The only downside of now this one, so I'm saying it is very easy to determine the volumes because of the color changes that will occur. The only downfall of this one is the size of the equation. Ndio hiyo sasa equations zinakuanga hivi. So the only problem now is the size of the equation. It becomes very big. Now, if you want to determine the ionic formula, now it becomes a little bit tougher. Yes, inakuwa shida kidogo. But actually, these are normally very interesting and very good, especially when you're doing the. So, I'm not going to tell you on that one today a lot. So, I'm not going to touch on that one today, but we'll touch it on. So, so most probably you might not be required to write the equations in the box because sometimes they are given. Yeah. So, unaweza pewa the equations, but sometimes you might need because of the mole ratio. Iko sawa? So this one now, I want now to Abdi, I want to help Abdi here, and then we end it there, and then we come and do a. Hii siwezi fanya nikiwa in a rush to go somewhere else. I want us hii tunafanya pole pole as a redox. So I'm trying to check. I think the meeting has started, but it is okay. It's something to do with the file. I'm still logging in using the same Zoom, but it belongs to Kemi, yeah? Kemi. What do you call is it education and Ministry of Education? It's just the school organized. It was organized in every school. So I want now to help Abdi before I leave. Apparatus and chemicals that we are going to use, we have Abdi Abdi during the titration. You will see something Abdi you will see a pipette, you will see 3 conical flasks. Now most of the schools do not provide 3. They'll give you 2. I pray that you are given 3, so that you don't have to waste time pouring out, and then because mine I normally the KCC they normally say give out at least 2. So if we were given 4, they don't raise up your hand and you say umenipea ini. Hata wanaweza kupea 10 because they are saying give out at least 2. So but for the titration process you need 3, only 3, which is okay. So 3 conical flasks, stand and clamp, one tile on paper. I explained the use of this one, everything. Funnel acidified, and then you have ammonium ion 2 sulfate solution, which is this one is tulifanya salts, eh? I don't know which is this a double salt or we have how many salts? I think we have 4 types of salts. So ammonium ion 2 sulfate. That one is, don't forget the types of salts actually, and at least one example or 2. So the procedure is the same. Pipette 25 centimeters of ammonium and transfer it into a conical flask. Yes. Clamp your burette and fill it with acidified. You see now what is happening. And then titrate until a permanent color just appears in the conical flask. The permanent color actually in this case is a colorless one. So it could change from colorless, which is ammonium 2 sulfate, to maybe purple, which is now the color of that particular manganate 7 solution. So it could be changing. So either now sometimes you are supposed to use potassium manganate 7 in there. So ikichangiwa ingine iende kwa burette, ammonium iende kwa burette na ingine iende kwa conical, you should not be worried. And then you record the. So repeat steps 1, 2, 3 to complete the table. Now, so we have the burette reading. Which one is the titer 1, final, initial, and then you have that one. So I'm now on Abdi before I leave. When you're filling this table, Abdi, there are 3 rules. Of course, those ones who are still there, we can see in idea bad. There are 3 rules that you are supposed to use when you're filling this one. Now, I'll just have to fill this table. So, rule number 1, make sure that you have consistent decimal places. And writing, for example, if the volume for ion is 10.0 that you have used there, 10, you don't write 10, unaandika 10 point. I have decided that we use 1 decimal place all through. Now, the initial reading is 0. You don't write 0. It is 0.0. Now, this one is correct. So, and then you minus the final minus initial, you get the volume 10.0. So, lazima kukuwe na decimal place. That is the accuracy of the burette. So, lazima uweke decimal place. That is number 1. Number two, when you are filling this table, the values should be making sense. The values that you use should be making sense. You write values that are making sense. You can't write for me 100 centimeters cube and the burette is 50. So you answer things, you write things that are making sense, values that are making sense. For example, I can put 11.0 and then I put 0.0. So hii inakuwa 11.0. Yani values that are making sense are those ones that cannot go beyond 50 or 80. Mtu anakuandikia 120 centimeters cube. No, those are not making sense. So the final right answers that are making sense. Yeah. And then rule number 3, which will help you answer question number A in exercise 2.2. Calculate the average volume of potassium used, average titer. Is you write values. Make sure that the values that you have written or that you have filled in that table, 2 of them, at least 2, should be having a difference of plus or minus 0.2. For example, what I'm saying is my answer, the third, and the last answer could be 11.2, which this one remains as 0.0, and this one now becomes 11.2, or this still answer can be 10.8, alafu niweke equal 0.0, alafu equal 10.8. Yani answer mbili zikuwe zimekaribiana by almost 0.2 or zitoshane ama zitoshane or zikuwe 11. So another answer, I'm only answering for 2, so another one could be 11, inaweza kuwa 10.8, 11.1. So there are very many answers, 11.1, 11.1. Unaona? So the answer that you get should be going from, you have answers that have a difference of plus or minus 0.2, na pia inaweza kuwa ya hii, so unaweza pata 9.8 ama 10.2 when you come to the lower side, yeah, which I normally advise students to use the lower side. If you use the lower side, the better when you use the lower side. So I hope we are okay. I don't know, I hope we are okay.
Yes.
Yes. So I think when we meet now on, hopefully Madam will continue from there on Monday. Hopefully she'll be in. She had some errands to run today. Otherwise she was supposed to be in today. So unless there is a query, Abdi, I hope we are together. But in the meantime, for the sake of understanding more, I want us to do. I'm going to share. Let me look for some questions. Then I screenshot and then I share. I'll screenshot and then I share some of the questions. You can try. Abdi, my number is always okay. You call me anytime. You share whatever you want to be assisted with, and then I'll help you. Yes. So unless there's a query, I want to end there for today. So I'll give you. I don't know. Can I give you this question to try out? What do
Okay.
you think? Yeah, I want you to try this one out. You just try the same thing.
Exercise 2.22.
Yes, I have the question. I have. So let me take a picture of this one. Yeah, I'll take a picture of this one, and then I'll share also the. Yes.
And the readings, give us an approximate.
Yes, I'll
Of
give
the
you the
readings.
readings. I'm sharing. Yes, I'm sharing all of them, inclusive of the readings. Eh? Watu tu
Okay.
wajaribu. I know you have not done it, but it is the same method. So I've taken a picture of that one, and then I'm going to take a picture of the reading. Maybe sample, maybe something you can get from specimen results. I'm going to give you these one to use as the specimen results. So you can see what I've shared.
In
So I'm giving you
the
this one as your yes. Let me give you the specimen results. So I've shared all of them. So let us try that question so that when we meet on Monday, if you finish it before, there's no problem. You just share it. You're gonna share that. So you share it so that we do it. And then now we can say, ukishafanya the redox, actually we can say you are ready for an experiment. So that means if I am to come to class on Saturday next week, I will not discuss a topic. I will teach you on practical, only practical, so that you be ready for the practical that you are supposed to be doing. Iko sawa?
yeah.
So unless there's a query, I'm seeing my meeting has already started. People have already moved a little bit ahead, but it is okay. I'll catch up. So there's no query. I wish you a very nice weekend. And please take care, especially those people who are around Nairobi. It's raining a lot, huh? Yes.
Have
Have
a
a
good
very
day, teacher.
beautiful day. Yes.
You too.